The ThermoMass sandwich wall system is the finest insulated concrete sandwich wall panel available in the world today. Our patented connector system has been extensively tested worldwide. Each connector can lift in excess of 2,500 pounds and has a shear capacity of over 900 pounds. Our fiber composite connectors are designed and manufactured to stringent specifications in accordance with traceable quality control procedures as required by the various building codes. But superior connector strength is just one of the many benefits of the ThermoMass building insulation system. Sandwich panels constructed with the ThermoMass building insulation system provide proven protection from heat and cold. Other systems may use metal connectors that penetrate through the insulation, connecting the interior and exterior withes. These typical sandwich panels will also incorporate solid sections of concrete, which result in thermal bridging between the two withes. These thermal bridges between the two withes, no matter how small they may seem, transmit energy through the insulation and result in wall temperature fluctuation. Independent studies performed by the United States Department of Energy have shown that the thermal conductivity of steel and concrete allows energy to transfer across and through the insulation. These tests determined that a panel's R value was reduced by over 30% with only 0.035% steel as a percentage of the total area of the panel. These same studies determined that the inclusion of solid concrete sections combined with the metal connectors resulted in loss in R value in excess of 60%. The best way to demonstrate this thermal bridging effect is through thermographic imaging. With this demonstration, we can show how energy will transmit through a typical sandwich panel and how energy will not transmit through a panel constructed with the ThermoMass building insulation system. Let's look at this side-by-side comparison. On the left is a ThermoMass sandwich panel section, a 2-inch exterior withe concrete, 2-inch insulation, and 2-inch interior withe concrete. The comparison panel is constructed with the same configuration. This panel, however, utilizes a solid section of concrete and 3 metal C-clips to connect the interior withe to the exterior withe, as is the normal method for construction. Using a consistent heat source to simulate the sun striking the exterior surface of the panel, the two panels were viewed with a thermographic infrared imaging video camera. During the examination, you can see that the ThermoMass panel remains blue, indicating that its temperature is remaining unchanged. No energy is passing through the insulation system. The typical sandwich panel on the right begins to show heat transferring from the outside concrete withe via the thermal bridges to the inner withe. You can easily see the thermal bridging created by the metal C-clips and solid concrete sections, and how this thermal bridging acts as a conduit for energy to pass through the insulation. As the heat continues from the outside, the ThermoMass panel remains unchanged, while the typical sandwich panel continues to glow hotter and hotter. Even after removing the heat source, the interior withe will continue to radiate the heat stored in the concrete for many hours before it returns to its normal temperature. The ThermoMass panel continues to remain unchanged, which means the interior climate remains unaffected by the changing weather conditions. To better illustrate the effects of thermal bridging, close-ups of each sandwich panel clearly demonstrate the energy efficiency of the ThermoMass building system, which in turn translates into tremendous cost savings. What is not as easy to see is the other benefits of the ThermoMass building insulation system. Other building systems have thermal bridges created by metal connectors that can create cold spots on the interior surface of the wall. These cold spots will allow moisture to condensate and collect. These moisture pockets are the prime breeding ground for mold and mildew. Additionally, solid sections of concrete bridging the insulation will allow the moisture that permeates through the wall panel to condense on the interior wall surface, creating the opportunity for mold and mildew growth. Composite Technologies Corporation utilizes state-of-the-art computer software called WFI. This program allows us to model the complicated geometrics of building components and then graphically analyze the heat and moisture transfer effects on walls prior to construction. Using a large database of materials and a weather generator, WFI is able to accurately predict a wall system's reaction to its surroundings. The ThermoMass system is the strongest, the safest, and the easiest system to use. The cost savings in energy alone make it the best choice for virtually any construction project. Our technical department is ready to assist you with engineering support, design details, thermal analysis, cost payback analysis, field technical support, thermal imaging analysis, and any other customer details needed to help integrate the ThermoMass building insulation system into your next project. Contact ThermoMass today for more information.